So I thought I'd just make this video to show some of the program features in Creo or Pro Engineer, which you're probably fairly familiar with if you've been seeking out this video. And what I've got here is a backing flange, quite a small one, as you can see, a DN50 size there. And in this one model, we can make a bunch of configurable models. So these flanges come in a whole range of different sizes depending on your pipe diameter. If you're an engineer or you work with pipe work, you'll probably be pretty familiar with them. But we can have one model instead of having several models or a whole family table of models, which is another way to do it, to configure which size we want. And as another little interesting feature, we can double this up as a flange backing ring or a blanking plate on the end, which I've added just to show a different example. So if we just go to regenerate, we're prompted with this little menu up here to just go with the current values that Creo currently has, enter some new ones, or read it from an external source, a file. So we're just going to use enter in this case, and I'm prompted for two entries, two inputs. So this is going to be the size, the DN size that the flanges go onto. And we can also configure with this one if it's a backing ring or a blank for the end of a pipe. So I'm going to select them both, or you can just use the select all command here and done selecting. And then we're prompted with some questions. So we're going to have to enter a diameter. So currently this is the current value up here showing 50. So I'm going to enter a new one and go for DN 250. And then the second question we're prompted for, this is a yes or no question, a Boolean. Do we want a backing ring? So select yes or no for an end blank. So I'm going to change it to no just to show the example. And there you go. So Creo regenerates a backing flange suitable for a 250 pipe to ISO standards. You should see the outside is 405 there. Just try one more. So back to enter, select all, enter. So we'll try 350. And we'll change it back to a backing ring. And there you go. So 520 up there. Okay, cool. Right, let's get started. So I'm going to start with a new part. You're probably pretty used to doing this. So I've called that one flange ring 1, so I'm going to call this one flange ring 2. Okay, so what I'm going to start off with is just doing an outer diameter. And the good thing about using these program features is it makes you really think about how things are modelled up, and it makes you model things that are ideal for change. Because you have two models, as you probably know, that look the same at the end of it, but one's really easy to modify and one isn't. So I'm just going to go for a circle for my outer diameter. Draw that in there. I'm assuming you're pretty familiar with basic modelling in Creo, so I'm probably going to rush through this a little more quickly. So we'll start with one example from a bunch of standard flanges here. So this is going to be the outer diameter. So I've just googled some flange sizes here. On this website's pretty good, metaludjog.com. There's some pretty clear tables to read, so I'm just going to use this one, ISO 7005. It's got all the dimensions I need on there. So I'll start with let's see, nominal pipe. So I'll start with a 200 here. So we'll go along here. We'll find our outer diameter from here to here. For a 200 is 340. So I'm just going to start off with that. It really doesn't matter which one you start off with because you'll put all the other values in. There we go. And we need our extrude thickness 40, so that's going to be a 26. So just OK that. 26 in. Okay, there we go. So it's almost like the blank with no holes in at the moment, but we're going to continue. So let's just start off with our holes. So what I'm going to do, which I'm assuming again you're familiar with, is I'm just going to do a remove material, extrude at the top, and then pattern it around this middle axis, which Creo puts in by default. Not sure you can see that the colours are a bit clashy, but yeah, Creo puts these in whenever you do a circle or a cylinder feature, or amongst others. So I'm just going to put it into this front face, or you can do it off the plane if you want, but it really doesn't matter. By the way, I'm just using the default references of the planes, which works fine for this example. Okay, so I think that is supposed to be 26. Nope, sorry, 22. 22. And this is going to be our pitch diameter here, or pitch radius, technically that dimension. So PCD 295. So I'm just going to do a little 295 over 2, because I can't do that in my head, obviously. Cool. So that's my first hole in the right place. Still sticking out. Yeah, thank you, Creo. We'll get to the net surface there. Yep, pretty happy with that. It looks like a hole. Cool. I'm just going to rename some of these extrudes over here, just keep it clear. So I'll just rename this one OD for outer diameter, obviously. And I'll just call this one bolt hole. I'm just going to pattern this around our center axis there. So I think it's 12 holes for our 200. Yeah, 12 equally spaced. So I'm just going to go for 12, and I'm just going to go for 360 for all the way around over 12 there. Cool. Neat little trick in pattern which people don't always use. By default, regeneration option is general, which is it works for a lot of scenarios if you're cutting bits off of certain extrudes in the pattern or whatever you've got. But when it's just pretty plain, you can go for identical, which speeds up your regen time, but it can cause problems if you're using fill patterns and other things like that. But we can use it here, so go with identical. Cool. So there we have our backing ring, basically already done. So we kind of want to go one further. Actually, I'll do that a bit later. So we'll just make it a backing ring for now. Okay. So since we have that, we want to go over to our tools and parameters up here. Now, this is where we want to define something for a user to input, basically. So since we've just got the backing ring at the moment, sorry, not backing ring, the blank, we've only got one thing for a user to choose, because we're going from that table of dimensions. So they just need to input the diameter of pipe, that they're the DN size. So I'm just going to call this one, say, input DN XXX. I'm going to change that to an integer, because it's not going to be, it doesn't require any decimal points. And we'll change it to whatever we're using at the moment. So we'll go with the 200. So that's simulating a user putting in the number 200. Okay. Then we need to go to our Relations tab, and this is where we build up the parameters behind the model. That when a user puts in 200, it then gives Creo a set of instructions to redimension the object to get the output that we want. So when you're in the Relations little window here, we do a / and an asterisk. It gives you a comment line, so that the program essentially ignores it. So I'm just going to start with a DN200 size here as a start. So DN200 size, give it a little heading. Okay, so probably come off that now to just show you the next little step, which makes life a lot easier. So we'll come off that. And what we want to do is actually name all our dimensions that we want to change to something a little bit more user friendly. So if we right click over here on the OD feature, on the extrude, go down to edit. At the moment we're given the actual value of the dimensions. What we want to switch to is the name of those dimensions. So there's a little tab up here, a little button for switch symbols. So go ahead and do that. And at the moment they're called things like D3, D4, P1. As we go through it, you'll see some other ones. They're not particularly useful names for us unless you remember things like that for whatever reason. So what you can do is just click on one, right click, go to properties here, and just call it something up here in the name field a bit better. So if we go for outside diameter here, I think that's pretty clear. Go to this one, give that one thickness. And as we click through our features, we can define different ones here. So the P dimension here is actually just a number. It's just a number of extrudes it's looking for there. So I'll go for number of holes. And the other one we want to change is this down here, which is the angle between the holes. So again, right click properties, I'll go for hole angle. Cool. The last one I think is this diameter here. I'll try and zoom in on that. No, there's another one as well. We want our PCD as well. So this one's just our diameter of our hole. So we'll go hole diameter, or maybe hole size. And the D8 here is our bolt circle. So bolt circle probably do. Cool. I think that is just about it. So we can click off a little bit. Now, if we get our window up again, relations again, just to remind you of the relations tab, relations button rather, under the tools tab. So the N200 size. Now, essentially, what I want to put in here is everything we've already put in, really, and it's going to go within an if loop container because we want Creo to check what our input parameter is from our parameters list, which you can actually see down here. You can get a little local parameters list down here. So I'm going to start with if, and these are pretty straightforward, especially if you're familiar with programming at all. But we're asking Creo if dn SSSS is 200, and remember to use two equal signs there. It's checking both sides. It's not trying to make one equal sign is trying to make one side equal the other. This checks them. There is a programming term that I've forgotten, which is more technical, but I hope that explains it. So if that's 200, and then we're going to put our body of all our parameters we want to change in here, but I'll leave that for now, and then just go straight to the end of our little container here, and it's an end if, no space between the end and the if. And that's pretty much it. And the way this works is we basically put our values in, and we'll make another if loop if they put in 150, if they put in 250. The most tedious thing about making one of these is putting in all the parameters from the table, but it doesn't take too long. And once you've done one, you know that the rest are going to work. So okay. So now we need to recall all our dimension names, and if you can remember them, great. Otherwise, if you just click on the part once you're in this relations window, and on your features, it will remind you what they are basically. And if you click in here, it'll actually just stick it in there for you. So here we are. We're just going outside diameter. We want to be 405. Is that right? That's to recheck my table. No, 340. Duh. 340. Once again, I don't need to type it, do I? I can just go thickness equals, once again, let's have a check. Oh, no, it's not doing that. Thickness 26. Right, let's just click on another feature here. Now, number of holes, even in this case, is 12 because I've just quickly counted them. I'll have a double check. Yeah, it's 12, and they're 22 mil size. As you can see, as you click through features, it actually accumulates them as you go, which is actually quite handy. And it can get a little bit busy. Hole size, so we said that was 22. And the whole angle here, remember you want to be, that's going to change. So you just want to go through 360 degrees divided by the number of holes you've got, which will space them out equally. And finally, I think, is our bolt circle, which is actually going to be half of the value here because it's defining a radius, so 295. 295 over 2 there. So that's it. So it's good once you've done that to use this little tick icon over here, which verifies everything and tells you if you've done anything wrong. Oh, I have done something wrong here. Okay, I just need to double check how I've laid that out. Cool, so I stopped the video there to find out what it was doing, and it just had some issue with this, putting this comment in first. So what I did was deleted this little bit out, then it was happy with that, and then I put the comment back in. I don't know, it's just a Creoism, which if you use the software, I'm sure you're used to, these little quirks it's got. But there you go. Okay, there's the fully formed expression as I did write it before. So I had no need to really worry. Okay. So if I just OK that and I try and change one of these diameters now, it won't let me. It will come up with a little message just down here on the bottom saying this is now driven by a relation, because now every time I regenerate the model, it's looking through that program. So what I want to do is go back to my relations and put another size in. So I'll copy and paste that down here. So we'll go for a DN250 size, and feel free to skip ahead a little bit here because obviously I'm just cross-checking with my table and putting values into these, so you might have got your head around this by this point. So 250, thickness 28, so I'm just going to whiz through these. What the hell happened there? Okay, looks a bit weird. I'll go with it. Yeah, it doesn't like that. I changed to 26 for this. Whole angle the same. Bolt circle on a 250. 355. So 355. Okay. So I'll verify those. Hey. It's always nice when you see that message, isn't it? You've done well. Right. So I'll OK that. Now, if I regenerate, there's no user input yet. I'm going to go through that in a second. But we can manually change this parameter, which is effectively doing the same thing. When I show you the design that you edit, you're just adding an extra step to this. You're asking for user input. So we've only got 200 and 250 sizes in. Obviously, if you want other sizes, you need to put them all in, as we just did. But I'm not going to go through all that because it's pretty long-winded, and it's basically a case of copying and pasting and putting new values in. Okay, so I'm going to go 250. Let's change that. Won't do anything immediately. I'm just going to take a little measure here just to show you something changes in case it's not obvious. That's 340. If I regenerate now, it has actually made that bigger. So now we're up to 405. Not always obvious to see with that one because it zooms the view. Okay, and I can change that back to 200 and it will switch back. Cool. Now to add in some user input for that, we want to go over to in this drop-down menu. So it's all in this tool section here. So down in model intent and program. Now you come up with a few options. The ones we're most interested in are the top two: show design, edit design. Show design just comes up with a little information window here for you to check through. And as you can see through here, our relations has actually been put into the model there. So it's a lot easier to write these relations within Creo because it transfers it over to this area here. So there's no point in really. It's just a bit more long-winded if you open this up and put these in first. I can't edit from here. It's just a show window. I'm not sure why they couldn't do both. But what we're going to add to now is this input area up here. And this is the area where it prompts a user to put something in. Right, so what we need to do is go down to edit design. Okay. Now what happens on my computer for some reason is it sort of tries to open it and then immediately closes it again. I'm not really sure why it does that. But if it does, it might open it in Notepad for you or Notepad++, depending what you're using to edit programs. But if yours is the same thing as me, just go to No over here, and it will keep the file open. It's like I'll show you. It's a program file that integrates into the part. So go to No. Now if we go to Edit Design again, it'll ask me if I want to open it up from the model again or open it up from a file. And what's actually happened is if we go to the directory where this is actually the working directory rather. Yeah. So we have a flandering2.pls file here, and this is basically the program that comes out the part. Why they gave it the playlist extension, I don't know. You might find it opens with VLC, or it tries to open VLC, which is what it did for me initially. But I'm going to open this up in Notepad++, which is I find more handy for editing a program with, but it's a pretty simple program, so you can just open it in Notepad really, it's also fine. And this is what we've just seen. Okay, so for the input section, what we're going to want to do is, and so I'm just going to pause a minute and just make sure I get this absolutely correct. 2 seconds. Cool. So I didn't want to waste time putting things in which weren't quite right and go through a boring error checking process. So here up in this input area, as you can see from my snip from another model, we just want to define that first parameter we have, our input dn epsets, which at the moment is set to 250, which we've changed manually. So I'll just copy it from my snip here. So we've got input dn epsets, define a number, and we can change this to whatever, but we'll leave it on 250 for now, which it will default to. And down here in the quotation marks, this is what the actual question that pops up asks. So enter nominal diameter. Okay, as you can see on this, I've also got an input for putting the blanking plate or the backing ring version on. We can actually put this in already because it will just define a parameter that doesn't effectively do anything for now. So I can put this one in. And again, you need to just define what sort of variable this is. So we've just got a number up here. Probably could be integer actually, but number works as well. I'm sure somebody could correct me on that one. Ring version, yes, no. We'll set it to yes, and just get it to prompt us. Select yes for backing ring, or no for blank. And input, I think we are happy with that. Cool, we'll give that a save. It does tell you if you've got anything wrong, fairly helpfully. So we just go back to our program here, edit design, from file, which is what we've had open, and ask me if I want to incorporate my changes back into the model. At this stage, if you've got anything wrong in that program, it will tell you here. In fact, maybe I'll do something wrong just to show you what happens. For now, I'll just do that. This might whinge because the file disappears. Oh no, it's still there. If I close it actually. Yeah. We'll leave it for now. We'll assume you got it right. What it will actually do, if anything is wrong, it will put a little comment in here and hopefully tell you the nature of what's wrong. Okay. So we'll just go back to where we were. So if we regenerate now, we'll now get this menu. So it allows us to go with current values, which will just regenerate, or enter some new ones or read from a file. So here we can now enter some. I'll go through it. So nominal diameter at the moment it's 250. We'll see them put in 200. That's the only two values we've got at the moment. You can put in brackets, a set list of values that the user can put in. I find that's the easiest way to do it. If you got quite deep into it, you could probably find some error checking mechanism you could use, but for the purposes of most models, it's not really necessary. So we'll go 200. This obviously doesn't do anything yet, but we'll change it to no because it is an end blank. Cool. There you go. Now, the other thing you can do with programming, which is just as powerful as changing dimensions and changing parameters, is that you can add and remove features. And when you do that, it can be really useful to, if you go up to your tree filters here, I've tried to leave my Creo as pretty default as possible to show you this video. I've just changed the background color here because I think white is a bizarre choice. So tree filters, tree columns, sorry, up here. By default, it just puts information in. It puts absolutely nothing else. So we're going to get to our feature ID here and add that one in. Apply that, and that, as you'll see in a second, gives us a little clue sometimes as to which feature the program is pointing towards. It does also have a name in there, but as you get longer trees, sometimes the feature ID is more useful, especially if you have things that are just called extrude 1, 2, 3, 4, which most models realistically are going to have, unless you've been very meticulous and you or somebody else who's made the model has named everything, which is unusual. So I'm just going to make an inner hole here. So I'll just do it off this face. Let's make a hole. I think we're on 200 at the moment. So I'll go back to my reference table. Inside diameter of 235. Sounds good to me. I've lost my... Oh, there it is. 235. Cool, and again... Cool, there we go. So we've made a back ring there. I'll call this ID over here, which makes life a little bit easier for us. Now again, this is another parameter we want to put into our relations. It's a new one. So for DN 200 size, again you can click on the part if you want. Actually, click on the feature is easier. Usually this, that's true. We need to actually change the name of it, don't we? So let's. Now you can just put D15, 16 like that in there, but let's come off this and give it a name. Yeah. Cool. You can just get the properties off. You don't have to switch symbols, by the way. Inner diameter. Cool. If I do switch symbols, it then comes up. Not sure why it asked me to do that. There you go. Cool. So now for our inner diameter. By the way, capitals and lowercase don't really matter here. It's quite a good practice sometimes to put user defined parameters as either capitals or lowercase, and then all the ones that are changed within the program as lowercase or capitals, vice versa, the opposites. I've not kept that discipline here for quite a simple model, but it can make things a little bit easier. I think that's quite good practice. Right, so inner diameter 235. 5 there, and on our 250 size again, 288. Cool, just check them through. Cool, verified. Cool. Now, if we don't change anything, that inner diameter is going to stick around all the time, which obviously is not ideal when we want to define an end blank, because whatever's in the pipe is going to come gushing out. Now, normally, if we, obviously want to get rid of a feature without actually deleting it, you can just suppress it, and effectively that's all we're going to be doing in the program by using Creo's default behavior when it comes to programs. So I'll go down to our program again. Edit design. Once again, it's asking me to do this, which is a bit bizarre. So I'll just go to. No, it's not in there now. Hang on, I just need to give this a save. I think. 102. Maybe that was a problem. So edit design. No, I want to click no, don't I? So it gives me the file. So here we go. Now this is a little bit trickier because you need to go through your model and find the feature we're after. So in this one, because it's not a very long program, we can pretty much just scroll through and find it. It's probably going to be at the bottom. But as you can see here, it can be quite hard to identify what feature we're looking at. But this is feature ID 66. Which we can cross-reference over here. So this is define our outer diameter, so we're not particularly interested in this one. This one can sit there just fine. There's also name down here. So I'm just going to copy that and search through our program because I want the one called ID. So there he is. So it pretty much the bottom of here is going to be the bottom of here, but if you've got a big tree, it can be pretty tricky to to flick through a lot of this stuff. Now essentially all we want to do here is just put an if loop, as we did in the program before around our variables, around the feature here. And it starts with the add command here. So add a feature and then end add down here. So from here to here is our feature defined. At the moment it's add suppress feature because I've suppressed it in the model. We just want to get rid of the suppress there. That wouldn't be there if I didn't suppress it. It does the suppressing almost automatically by its default behavior, as you'll see in a sec. So what we need to do first, actually, before I do that, is define a parameter. Oh, we did do that already. That's actually been generated from the program we wrote earlier, so that's quite handy. But I need to look at the name of it anyway, so I've called it ring underscore version. That's a yes or no. So again, we want to go if ring version double equals. If you're getting errors in the program, that's a good one to look for. If ring version equals, what we're doing here, yes, because it's a feature I want to add. So basically, if this turns out to be no, it automatically suppresses this feature, and we need to define where this ends. So you could put this around 2 features, 3 features if you wanted to, if they happen to be in line quite neatly. So we'll put it out to the end add and end if. Remember, all one, different to end add. No idea why. Cool. So let's try and integrate that back in and see if that works for us. Yeah, that's worked. It's not chucked up any errors for us, so we'll incorporate that there. It's actually asking us for input already, so I'm going to go ahead and enter them both. So I'll change it back to a 250, make sure that still works. And we'll change to a backing ring, yes. And as you can see, it's put in our inner diameter feature. We'll just come out of that program mode. We'll just test that again. Just the ring version this time, go for no. And just fill that in. Now, we're pretty much done. That's all I wanted to talk you through, really. So what you want to do, if you want to make one for every possible size, you're basically just copying and pasting all of this. It's always good to have a little header to remind yourself what you're doing. So 300 size, again, you know, if the user puts in 300 is what that line is asking, then set this bunch of parameters. So outside diameter on a 300 is, oh, it's not on there. Oh, that's annoying. Oh, maybe it's that one. Yeah, but whatever. You know. Yeah, I think it's that one. So you just put in another set of values for it to look at. Or you know, you can go down to little diddy sizes, DM50 sizes, and put in all the values for that. So there you go. If you found this helpful, if you've got any comments, any feedback, obviously this is the first video I've made like this. Please do let me know if I've missed anything out, I can show you anything else, etc. Let me know. Cool. Thanks for watching.